बस एक क्वेश्चन गिवन है यहाँ पे फाई का वैल्यू दिया है अपने को डी की वैल्यू निकालनी है 2π/2 और 0 पे. सो वी नो व्हाट इज डी इक्वल टू एप्सिलॉन टाइम्स ई. And how we calculate E equal to minus del V, and was it del here in polar coordinates del by del r r cap 1 upon r del upon del theta plus 1 upon sin theta del by del phi. It should be remembered. There is minus del by del r cap plus 1 upon r del by del theta cap plus 1 upon r sin theta del by del phi phi cap. So the value here given is phi is 10 upon r square. So 10 minus 10 will be 1 upon r square differential minus 2 upon r cube sin theta cos phi r cap plus 1 by r del by del theta theta cap. So cos phi will be out and cos theta sin theta derivative will be cos theta, and again it will goes on 1 upon r sin theta 10 upon r square sin theta and cos phi equal to differential cos phi minus sin phi. So in next step what will you calculate? D equal to epsilon naught times c. So multiply this whole thing with epsilon naught times. So we are left with this part same. Now D is 2π/2 0. So what is r is 2, theta is π/2 and phi is 0. So you are left with minus 10 upon epsilon naught minus 2 8. Let's put here r is 2, so 8 sin 91 cos 0 1. Same here cos 90 0 and sin 91 and sin phi 0 sin 0. So only we are having the radial component, that is minus 2 8 r cap. Now solve it. So you are getting 5/2 epsilon naught r cap. What is this? D by 2π/2 0. So this type of question also may be asked in your examination. You have to take a look and must remember these things, how we will solve. Basic thing to remember in this question is the value of del. Most of the things you know, but the value of del you should remember. What is del? Del by 1 upon r del by del r r cap plus 1 by r del upon del theta cap plus 1 upon r sin theta del by del phi phi cap. Del by del r r cap plus 1 by r del by del theta cap plus 1 upon r sin theta del by del phi phi cap. This thing should be remembered, and remaining things you will go when you calculate. Eventually it will happen. Now we know that phi closing equation method ds, and from this we can also convert it into d to ds, and we know work done is total kinetic change in kinetic energy plus potential change in potential energy, and external work done is F dot dr. We know this. So here we can say that external work is minus F electric, because when you look at this here, F equal to Q by E. So what you will get? You get F net, it's M A net, and when A net is 0 we say V is constant. Now why we are studying this? Suppose we are given question, a polarization is given and we want to calculate V. So we know potential is Kp cos theta by r square. So here our point is 0 0 and 0 0 minus 2. So theta is 0 and r will be 0 minus 2 equal to 2, and theta is 0. So Kp upon r square, and r is 2. So 2 square equal to 4. So when you calculate, when you put the value and calculate it, what it will give you 11.25 volt. It can also be written as Kp dot r upon r cube in vector form. If there are two distances are there, then r1 cube r2 cube. So here r1 0 0 0 0 minus 2 is 2 cap and r2 is 3 cap. Just put here and you will eventually solve the question and choose the MCQ type right option in the given the question. Now the volume is 6 rho upon 6 upon 3 r square minus r square, and this is the potential. Okay, we know this. This is just revising. And when this point is lies outside the radius is rho naught r cube upon 3 epsilon naught r. Similarly, V equal to minus E dot dl. So it will be rho r upon 3 epsilon. We know inside the sphere uniformly charged sphere, and outside rho 1 upon 3 epsilon r cube upon r square r cap. So we will be 2 by rho naught square r cube of 5 of 45 epsilon naught. Now inside electric field of uniform charge sphere is E surface multiplied by r by r. So it will written as kq upon r square r by r, and it also can be written as kq r upon r cube. Now if you have j is 1 by r cube 2 cos theta r cap plus 1 sin theta cap a per meter square. So we want to calculate the current passing through hemispherical share of radius 20 centimeter and it is given that theta is 0 to pi by 2. So we know that this is hemispherical cell, and phi is whole. This is phi, and this is theta from this to this. And so what will we want to calculate? Current. So what is current? Current is I equal to j integration to d integration j to d, and here radial component dr equal to r square sin theta dr theta d theta d phi r cap. We know this, r square sin theta d theta. Just put it here. This small thing will decide you will able to do questions or not. You have to remember the radial surface area. So it is r square sin theta d theta d phi. This is r square sin theta d theta d phi. So just put here and put theta 0 to pi by 2 and pi equal to 0 to pi 2 pi. So 2 pi 0 to pi by 2 2 by r cos theta sin theta theta के तो 2 cos theta sin 2 theta the integration will be cos theta divided by 2 0 to pi by 2. Put cos 2 pi by 2 cos pi cos x cos c cos 180 minus 1 minus cos 0 1. So minus 1 by 2 2 cancel 4 pi by 20 1 by 5 pi. So it is 10 pi. Again for 10 centimeter, if potential is 0, in this condition you are having 0. Again next question, for the j equal to 10 z sin square phi rho cap ampere per meter square, find the current through the cylindrical surface rho and z. So d is rho d phi dz rho k cap, and rho is 2 phi 0 to 2 pi. So let's integrate this. Rho is 1 to 5 and phi 0 to 2 pi. So you are having 2 into 10, z is equal to square by 2 1 to 5, and sin square theta equal to 1 by 2 1 minus cos square theta. So 1 integration will be 2 pi, and cos 2 theta is sin 2 theta by 2, and sin 2 pi this will be 0. This will give you pi. Put it here. You are having 240 pi will be the answer. So what you will calculate it? Cylindrical coordinate d rho d phi dz. You should know this. Okay. So before solving the question, you should have a clear cut mind map in your mind. किसी भी क्वेश्चन को अप्रोच करने से पहले आपके दिमाग में चीज़ें क्लियर हो जानी चाहिए कि आप उस क्वेश्चन को सोल्व कैसे करने वाले, बिना करे। कैसे? आपने को जे दिया, पूछा करंट, तो आई इक्वल टू जे डॉट डी लगेगा। अब यहाँ के सिलेंड्रिकल डी है, सिलेंड्रिकल में डी क्या होता है? रो डी फाई डी जेड होता है। बस फिर खेल खत्म हो गया। फिर तो क्वेश्चन। अब थोड़ा सा स्टडी करंट के बारे में पढ़ लेते हैं। क्या होती है स्टडी करंट? कॉन्स्टेंट डीसी करंट है ना। अब लैंग्वेज का कोई वेरिएंट नहीं है, थोड़ी सी हिंदी थोड़ी सी इंग्लिश भी यूज़ कर सकते हैं अपन, थ्रू आउट इंग्लिश भी यूज़ कर सकते हैं ना। तो कमेंट में लिख सकते हो तुमको जो सी भी लैंग्वेज कंफर्टेबल है। सो कंटिन्यूड इक्वेशन क्या है अपने? डेल रो वी बाई डेल टी प्लस डेल डॉट जे इक्वल टू 0 फॉर स्टडी करंट डेल रो वी बाई डेल टी इक्वल टू 0. So del dot j will be del rho v by del t 0. This is called steady current case. Why it is so? Take j equal to sigma e. When you take divergence of E, rho v upon epsilon, we know this. Divergence of E equal to rho upon epsilon, Maxwell's specification. So put here, put sigma in E. So you will get sigma here also, and it will sigma rho v. What is sigma rho v? Del rho v by del t. Getting my point or not? So here it can be written as del rho v by del t plus sigma upon rho del v equal to 0. Next following we get del rho v by del rho equal to minus sigma upon epsilon del t, and when you integrate rho, we are getting rho v equal to rho v naught e raised to the power minus t upon tr, where tr is relaxation time is epsilon upon sigma. Very important. Okay. Relaxation time is very important. What is this? Epsilon upon sigma. What is this? The time by which initial charge density rho v naught decreases by a factor of 1 by e. This is called relaxation time. Now for ideal conductors it is approximately 0. For good conductors it is short, and for ideal dielectrics it is infinite. For ideal conductors it is 0. For good conductors it is short, and for ideal dielectrics it is infinite. Okay. So for ideal conductors reaction time is 0. For good conductors reaction time is very short, and for ideal dielectrics it will be infinite. So basically it is negative impact. Okay, reaction time is negative impact on conductivity. Getting my point? Reaction time is negative impact on conductivity. Thus you can remember it. सो आइडियल कंडक्टर क्या होते हैं, बहुत अच्छे होते हैं, तो इनके लिए क्या होना चाहिए, रिएक्शन टाइम 0 होना चाहिए। गुड कंडक्टर अच्छे तो होते हैं, तो इनके लिए थोड़ा कम होना चाहिए। और डाइलेक्ट्रिक क्या होना चाहिए, इन्फिनिट। नाउ फॉर फ्यूज कंडक्टर्स इट इज 10 to minus 17 Siemens per meter, so 5. So reaction time will be 5 on, we will solve this 51.2 days. Find out the reaction time for mica. It is 10 to minus 15. Hope you are able to listen my voice. Sigma is 10 to power minus 15 Siemens per meter, epsilon equal to 6 for mica. So we are getting 15 hour approximately. Now when we are applying potential to a conductor, in this condition electrons are never colliding to each other, because in root theory we are considering that they have negligible volume, so they collide with only the lattice. So Vd equal to del x upon del t, we know the velocity, and the rate of diffusion is from Graham's law is 1 upon log t, means density, d is density here. Now sigma upon sigma, or what is epsilon or sigma, doesn't, if this epsilon or sigma does not vary with the region being considered, and it therefore same at points. These are not varying, and these are independent of coordinates. Then in this condition they are saying homogeneous medium. Then when permittivity or sigma medium is function of space coordinate, then what will say, these mediums are known as inhomogeneous. Okay, so inhomogeneous or homogeneous depend on that whether they are changing with their variables. I have written down there like this. Isotropic medium, no, where I had written this. Okay, chalo, let's consider now isotropic medium. Some decision marking. This medium has same dielectric constant all the direction. So isotropic medium are basically related with the dielectric direction. Basically related with the direction. So dielectric constant will not change with the direction. In these materials, E and D are in same direction. For anisotropic material, what is happening? What will happen? Dielectric constant is different in different direction. Anisotropic and isotropic. Isotropic dielectric constant is same for all direction, and anisotropic dielectric constant different for all direction. And of course there is a tensor quantity for anisotropic media. Now for dielectric media. Now for any dielectric medium is linear. Why? When it will be linear? When epsilon does not changing with the E applied. Okay. So whenever we are applying epsilon electric applied and epsilon is not changing, then we say linear media. And when we say homogeneous, when epsilon does not changing with point to point. Okay, we are changing point from x to x prime and it's not changing, then we say homogeneous. And after changing direction it's not changing, then we say isotropic media. Now we will consider about uniqueness theorem in our next lecture. Thank you.